What's going on, guys? So we are still out here at Lippert, and we are at several of their manufacturing facilities. So the last video we were in that one over there, and that is the beam processing facility, basically where all the raw material comes in and they process it and get it ready for this plant and several of their other plants. The plant we're at now is plant 19. This is their fifth wheel frame facility. So this specific facility is what takes the raw material that comes out of here and converts it into actual fifth wheel frames. So you see the material out here, and before it actually gets turned into a completed frame, it is going to be powder coated. So we'll go over that process probably in another video, simply because we don't want to make each one of these videos too long. But yeah, the raw material then leaves this facility, enters this facility, and this is where they start constructing fifth wheel frames. So we're going to kick this video off. Hang tight, I'll be right back. Now, it might be very, very loud in here. I have hearing protection in at the moment, so I don't really know how loud it is, but hopefully you can hear me. I can't tell how loud it actually is. It's pretty loud.
We're here to see the welding of the fifth wheel chassis. So the basic process is we pull our carts full of I-beams we made in our beam processing center in here, and we're building off a production schedule. We're building off a run of chassis. We've picked all the parts from our warehouse for that sort of chassis, brought them in, staged them into the production line. The carts are in. We've moved the I-beams over into our jig here. That helps us keep everything square and true. And then we're going to start going down and welding all the different cross members and outriggers and components into the chassis. Okay. According to the blueprint and following all the markings that were put on during the beam processing center.
Now, I'm assuming this one back here is going to be a toy hauler, simply it has that dovetail coming out.
Absolutely,
right?
Yep. Once the frame is fully jigged up, we call it, all the axle hangers are welded on, all the cross members and outriggers are put on. We mount the upper deck. They weld upright risers on to the main rail, and then set the upper deck on top of those risers and weld everything together. These are actually some really good looking welds too. We have a pretty rigorous weld training program that all of our welders go through and are certified through our certification process.
So how many welders do you have?
About 600 welders.
100 welders. Wow.
So,
wow, that's a lot.
in this plant we have 19 production lines with about 8 to 10 people on each line welding. Once the upper deck is set, the chassis moves forward into our finish station, where our finish welders put any kind of finishing welds on. They install any slide outs in the chassis, and the quality inspection gets done, and then it's out the door.
Let's go look at the upper deck on this one, if that's okay. Okay, so this obviously is not a drop frame unit. That's a continuous I-beam. Again, I have a feeling, it doesn't look like it's a soy hauler because it doesn't dovetail with the end of it. So when it comes to engineering the riser, I can see how you have some vertical posts here, but then you put a flat plate right there, and that creates the rigidity up there on the net.
That helps with that, but the main purpose of that is to patch this off. A lot of times there's an LP tank right here that ends up needing to be sealed off from the inner compartment. Okay.
So whenever you're talking about where frames are designed to move and how they're designed to work in conjunction with the box, I see on this section right here where you have these outriggers. And when the floor system goes on, it's attached to these outriggers, right, with bolts.
Correct.
But the upper deck, it extends the entire width of the RV.
Correct.
So the floor system has to be properly attached to the upper deck and not outriggers, correct?
Correct.
All right. Is there a guideline for how you attack the flooring system, or how an RV manufacturer would attach the floor system?
No. At the end of the day, it's really up to the manufacturer how they attach that. We've given some, recommendations, but it's really depends on how they want to manufacture their unit.
And that can all probably play into how structurally rigid the RV is, right? Their attachment message. So you give them recommendations.
And you can see here, we provide all the lag holes. So this customer's using a horizontal and a vertical lag to lag their floors, and they may choose to use some glue as well to mount that sidewall, attach that sidewall to the upper deck structure.
You produce several different variations of I-beams for different gross vehicle weight rated RVs, right?
Yep. This is one of the heaviest duty that we use.
Okay.
That's the 12-inch, 10.8 pound beam, I believe, on this one.
So this is, I guess you call this the header tube, right?
Correct.
So this is the header tube, 1/4-inch thick. They also make this in a 6x8. So this is a 6x6, and they have a 6x8 depending on the weight, the gross vehicle weight of the RV that it's going to be applied to. Right? Exactly right. Very good. So that is not thin material. And again, when they put the extra reinforcement on it, that all creates that rigid material. If you just have this as a box section, it's strong, but it becomes much stronger when you engineer it as part of an entire assembly.
That's and these brackets here, like holding the pin box on, these are also 1/4 inch. So very thick and designed and welded all the way around to put the stresses in the best place in the structure. We always design with a safety factor in mind. Okay. Absolutely. We never design just for that limit. That's not a good practice.
Okay, so we are hunting down a drop frame. This right here, no, I'm guessing it might be an Alliance. Oh, right here's the drop frame. So just because you see a slightly shorter I-beam doesn't necessarily mean it's going to be weaker because they use a heavier gauge steel on the beam. Right. Let's try to get out of their way. They're trying to work here. And then they also have a box section underneath the suspension area right here. Is this box section primarily for height? Is that why they bought it, or is it also for rigidity?
It can be there for different reasons. Sometimes it's for height, sometimes it's for strength. And we've got different sizes, 2x2, 2x3, 2x4. So again, we're engineering that specifically for the application.
And I've noticed that you guys have been doing your reinforcement on your shackle hangers for a few years now. That's becoming a pretty standard practice on almost all the frame types.
It depends on GVWR and the height of the hanger, and then OEM standard as well. Some put it on standard, some don't. So the manufacturer dictates that. We have guidelines where it's a must. We demand it, but then there's some options for others.
So on any RV, any frame, a manufacturer could say that I want this, and you can put it on.
Put it on.
Okay. So again, this also comes down to what a manufacturer is willing to pay for and what they want on their RV.
Exactly.
Okay, so in front of us, you're looking at a standard up and down. A lot of people might ask, well, if the space saver system is kind of the evolution because of how it gives you extra space up front, why don't all manufacturers use it?
Some manufacturers are comfortable with what they've used for years. They don't see a problem for it, so they don't see the advantage to change. So in those cases, we try to tell them the advantage, but ultimately, it's up to them. If they don't want that flexibility in their floor plan, if they don't feel they need the extra strength, then that's their choice.
And it's entirely up to them. And you probably even, I'm going to use the term sell them on the benefits, but they're like, you know what, we're fine with the way it is. Let's keep it the way it is.
That's right. And ultimately, it's their name on the unit, and they get the next.
Okay, great. Thank you. Just so you guys can see what it takes to make a fifth wheel frame, the different types of fifth wheel frames, the different types of materials different manufacturers might specify in their frame design. Here's another big I-beam. A lot of stuff going on in here, but again, a lot of it comes down to what the RV manufacturer specifically is willing to pay for and specs into their design. Okay, so we're going to head out from here. We're going to go to the powder coating facility next, so you guys can get an idea of what they do to protect the frame. Okay, so it's going to be really loud. We tried laving up with lav mics, and that really didn't help us very much. So we're just going to try to talk really loud.
So real quick, I'd like to also mention all these chassis out here were just welded today. Within hours, they'll be into our powder coat systems and coated and through and we're ready to ship. So we build something today, we weld something together today, it's out to the customer within the next 24, maybe 48 hours.
Yeah, so for the chance for any type of serious rust to form is pretty much non-existent.
Right.
But I do have a question for you. So whenever we talk about the number of RVs that are going to go in here, or number of frames that are going to go in here today, how many frames on average would you say you guys build per day?
Right now we're at about 1,000 chassis a day out of our facilities here in Elkhart County. At the peak of demand, we were at about 2,000 chassis a day, 2,000 to 2,500 chassis a day.
1,000 chassis per day, supporting how many manufacturers roughly?
You know, we have, I think, about 135 ship-to locations around the area.
Okay, so when you say 1,000 per day, you've had to make sure that the technology is in place to be able to actually support that type of development. So a lot of people are like, why do you build them so fast? Why do you do this? The fact is you have to innovate because your customers, you have a lot of them.
Right.
And they need their frames because without their frame, they can't do anything.
Right.
They can't build an RV at all. So they're producing 1,000 frames roughly a day. So when he says all of these frames will have been cycled through, that's exactly what he means. I mean, these don't sit out here very long because they got to get these things cleaned off, powder coated, and sent to the manufacturer.
Correct.
Okay, let's get a tour of this place.
All right, so the first stage, you see that these things can get wet. You know, if it's snowing out or icy, they can get some ice and moisture on them. So the first thing we do is we bring them into our dry-off oven. We basically bake them at 350 degrees to get them all completely dry to get ready for the shot blasting process.
Okay. Big toy hauler frames right here, I can see.
So once the frames are all dried off in our dry-off oven, they move into our shot blasting process. We use a stainless steel media to blast off any rust or mill scale that's formed on the steel. Okay. And we have a small crew of people in here that are manually doing that because they have so much variation.
Yeah, you don't know where surface rust could have formed,
right?
And you want to be able to get to where it's at.
And we're blasting every square inch of these to get it down to raw metal. Yep.
Very good. Do we have a raw metal frame we can look at?
Well, let's take. So here you can see what it looks like after it's been blasted. It also, besides just taking off any rust and mill scale, it adds a profile to the steel that helps the powder coat adhere.
Yeah, for sure. Very nice. All right, let's get out of here so they can do their job. And this is a massive facility.
So the next step is the actual application of the powder coat. The frames are going to be grounded, and then there's a charge put onto the particles of powder coat, and we have 8 to 12 people applying the powder coat within this booth on a typical day. And so once that powder coat adheres, it's going to get moved on to the oven to get baked on after that.
Okay, maybe I can stick my camera in there real quick.
Sure.
Okay, so as people can see, they stack multiple frames for efficiency to be able to get more through. But from a spacing perspective, how do you minimize the gaps in powder coating between the different frames that are stacked on top of each other?
Yeah, so there's a 4x4 block that separates the chassis, but to minimize the amount of untouched area by the powder coat, we're putting some spacer blocks that actually create just a thin touch point. Okay. And that's how we try to minimize the amount of uncovered space.
And that's with any powder coating process.
Anybody that powder coats, somewhere you have to touch a part to hold it as it goes through the process. So there's going to be a small void on anything.
Okay, so we actually have 3 travel trailer frames that have come out of the oven. These things are ready to go. Really, really nice finish. I mean, this is the condition that you want to get your RV in, right? This is what you want your frame to look like. So part of the process here is once it leaves here and it gets shipped to a manufacturer, and as you can see, they don't ever come with axles or suspension or any of that in place. That's all added by the RV manufacturer. So whenever you see, whether it's even a LIPPERT component, if it's like the road armor, they don't put it on here. They sell it as a separate component to the manufacturer. Then the manufacturer of the RV installs it. So the manufacturer can pick whatever suspension, whatever axles, whatever tires and running gear they want to put on the RV. This right here is purely the frame, the hangers, and everything that you attach that stuff to. And you can see it looks really, really good. to be honest with you, I'm super impressed with what I've seen. I really am. And it just shows you that if a manufacturer wants to use thicker material, wants to use certain materials in certain areas that they think will perform better, it's up to them to specify that to Lippert. But Lippert gives manufacturers a lot of recommendations on what they should do. But ultimately, at the end of the day, it's a part that they're selling to the RV manufacturer, and it's really up to the RV manufacturer to select the parts that are best for their application and for their customers and for long-term reliability. Whenever it comes to building a frame, it really comes down to the RV manufacturer telling you what they need, what they're trying to build, and because you're building the part for them. You're building a component for them, and if they want it to be more structural in a certain area just for overkill, just to say that we did it that way, they need to specify to you, and you will build it to those specifications for them. Yep. So I see a lot of frames that have a lot of extra rigidity built into them in certain areas, and that's because, like, Alliance says we want that in that area, right? So you build it to meet that specification. Right. Very cool. Well, I'm super impressed with what I've seen. The entire process, honestly, is eye-opening, especially to someone who reviews RVs. I stand on thousands of your frames, but I never really think about much more than saying, hey, look, that's a 12-inch I-beam, or that's a 10-inch I-beam. And what I really like is in your frame factory where you're assembling fifth wheel frames, how if you go to a shorter section of I-beam, it's typically a thicker section of I-beam. So it may be shorter, but it's going to be a heavier duty section of I-beam to support more weight. Where some manufacturers might go with like a 10-inch drop frame, some might go with an 8-inch drop, but then you design that section adequately to support whatever application they need.
That's right. The length of the drop, all those things are important factors. If there's slides in there, you know, that's how we decide what beam to use.
And engineering goes into all of it.
Every single component.
Yep, very good. And these are real engineers, so that's the key. You have to have an engineering degree, probably mechanical engineering is what I'm assuming you're hunting for. And I'm assuming you're even looking for engineers all the time.
We are, yep.
So there you go. Anyways, guys, I really appreciate it. This is super cool. I know it's still really noisy, but heck, we're in a factory, so it's going to happen. But again, eye-opening. If you haven't seen the first two videos, go back and check those out, because it's very, very eye-opening and inspiring to see what they do when the raw material comes in, processed, moved over to the frame facilities, and then sent to powder coat. Very impressive, guys. I appreciate it. Thank you so much. Guys, if you haven't had a chance, please take a moment, subscribe to the channel, give me a thumbs up, and we'll talk to you again very soon.